In this tutorial, I'm going through 2023 Paper 1 Question 5, and it's all about differentiation. And the content covered in Part A here, you can find similar questions in Differentiation 8 on the website. So in this question, you're asked to get the derivative of 1 over 5x squared plus 7. Now you can use the quotient rule to do this one if you want, but it's a bit longer, and I think you're better off if you use the chain rule. So that's the way I've decided to do it. If you want to use the chain rule, you have to simplify f of x before you differentiate. So you should recognize you've 1 over 5x squared plus 7 to the power of 1. If you look at the rules of powers from page 21 on your maths tables, you can take the 5x squared plus 7 and put it on the top of the fraction if you change the sign in front of the power. So instead of being to the power of 1, it's now to the power of minus 1. And like the 1 here, we don't need to worry about the 1 there. So basically we just have to differentiate 5x squared plus 7 to the power of minus 1. We have to use the chain rule to do it. So you bring the power in front, that's where my minus 1 comes from. The bracket stays exactly the same, and then you decrease the power of the bracket by 1. So minus 1 becomes minus 2. Then the last thing is you multiply by the derivative of what's in the brackets. The derivative of 5x squared plus 7 is simply 10x. And then it asks you to simplify it, so I just need to simplify this a little bit. I multiplied minus 1 by 10x and got minus 10x on the top. I then used that rule of powers that we talked about in the first line, but in reverse. So if I have 5x squared plus 7 to the power of minus 2, you take it down underneath the fraction and the sign in front of the power changes. So instead of being to the power of minus 2, it's now squared. It's to the power of 2. And that's your final answer for Part A. In Part B of this question, we're told that g of x is tan x over 2 times ln x. And we're asked to come up with the first derivative and get the first derivative at pi over 2. And leave your answer in the form a plus ln b. So the first thing you should recognize is that the only way we're going to differentiate this is using the product rule. So we have to start with our product rule. And if you want to see similar questions to that, look at differentiation 6 in the tutorials. So essentially we take the first part of the expression of the equation as u, the second part as v. So u in this case is tan x over 2. And the derivative of tan x over 2 is sec squared x over 2. But then you have to multiply by the derivative of the angle. And that's where the half is coming from. Some students tend to struggle with that, but it's quite straightforward. If you have x over 2, the way you should view x over 2 is the same as a half x. And if you differentiate a half x, you obviously just get a half. You know, you have x to the power of 1, the 1 comes in front, and it becomes an x to the power of 0. So the derivative of a half x is just a half. So that's where this half comes from. Tan of x over 2 becomes sec squared x over 2, and then you multiply by the derivative of the angle, which is a half. And then our v is ln x. The derivative of ln x is simply 1 over x. So now that I have u, du dx, v and dv dx, I can just sum into the formula for the product rule and then try and manipulate it until I get to the final answer. So I've simply subbed into my product rule here. The first derivative is u times dv dx plus v ln x times du dx, which is a half sec squared x over 2. And now I just did a little bit of simplification. Sec squared, like we're going to have to sub in for sec squared, and there's no button on your calculator for sec, so I decided that instead of writing this as sec squared x over 2, if you go to page 13 in your maths tables, it'll tell you that sec a is equal to 1 over cos a, so sec squared x over 2 is the same as 1 over cos squared x over 2. And at least we're going to be able to sub that into our calculator when it comes to that. On the next line now, I decided to sub in. Everywhere there's an x, we now sub in pi over 2. So all I've done on this line is instead of an x, subbed in a pi over 2, and then simplified a little bit. Here I have pi over 2 divided by 2. And if you plug that into your calculator, you'll get pi over 4. Here I have 1 divided by pi over 2, and that's 2 over pi. ln pi over 2, we don't need to do anything with that because we want an ln in our answer, so there's no need to worry about that one. Here I just left a half as it is, and then pi over 2 divided by 2 becomes pi over 4. Now you can plug a lot of it into your calculator and it works out really nicely. Make sure your calculator is in radians. Tan pi over 4 is simply 1, and 2 over pi, I left it exactly as it is. left the ln as it was, left the half as it was, and if you plug this into your calculator, cos squared pi over 4, I want you to remember that cos pi over 4 squared and cos squared pi over 4 are the same thing. So type in, for example, cos pi over 4 into your calculator and then get it squared. And then 1 divided by that, it'll give you 2. That's how you work out your 2 there. And then here it works out nice because 2 multiplied by a half is simply 1. So the second term just ends up as ln pi over 2. And my final answer is 2 over pi plus ln pi over 2. In part C, we're talking about composite functions. And we've studied composite functions from functions 4. So if you want to practice more questions like this, go to functions 4 and look at a few of those. This was a strange one, but it's relatively simple. We have a mapping diagram 1, 2, 3, 4. And then if you apply the function f to that mapping diagram, it shows you what it becomes. And we just have 3 diagrams. It's a plane, a globe, and a cloud. And then if you apply g to that, it shows you what that becomes. We're asked to work out g of f of 3. Well, first of all, f of 3, if we're at 3 and we apply f to it, that brings us to the world, the globe symbol here. And then if I'm at the globe symbol and I apply g to that, you just follow the arrow on and that brings you to w. So your answer here is that g of f of 3 is simply w. And in C part 2, we're asked to explain why going from B to C is injective but not surjective. Remember that injective means that every output has at most one input. So if we look, we're looking at going from B to going to C. And essentially the thing that you're looking for to investigate if something is injective, the thing that we don't want to see is the likes of what's going on here. Do you see where 2 and 3 are both going to the globe? That means that that's not injective. Essentially you can't have 2 arrows going to the same dot for it to be injective. So you here, to say it's injective, you say that every output has at most one input. So none of the 4 outputs, X, W, Y, or Z, have more than one input, so that makes it injective. Then you have to describe why it's not surjective. The reason that it's not surjective, it's basically because of the Y here. If something is surjective, then the codomain is equal to the range. In other words, all of the possible outputs are being used. So if it was surjective, then every single one of the dots on the right-hand side would have an arrow going to it. So in this case, the codomain is not equal to the range. And if you want to express that even further, you can say Y is not busy. The reason it's not surjective is because of this Y. There's no arrow going to the Y. That means it's not surjective. There's an empty output which you can't have if it's surjective, but you are allowed to have it if it's injective.